Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 16th February 2023. The problem statement for today is good stones. This problem is based on dynamic programming concept of graph. Let's now open this problem. So first we will go through this problem statement clearly. Here it says Geek is in a geek land which have a river and some stones in it. Initially, geek can step on any stone. Okay, so he can start with any stone. Each stone has a number on it representing the value of exact step geek can move. If the number is positive, then geek can move in the right, and if the number is negative, then geek can move left. Okay. Bad stones are defined as the stones in which if geeks steps will reach a never ending loop, whereas good stones are the stones which are safe from never ending loop. Return the number of good stones in river. So here it is trying to say that there is a one river and some stones are there, and each stone has some number associated with it, and if the number is positive, then the user or the geek can move in the forward direction, and if the number is negative, then he can move in the backward direction. But there are some traps also. Here some numbers are there in such a way that it will keep geeks rotating in the infinite loop. So we need to avoid those bad stones, the stones which are part of this infinite loop, those has been referred to as bad stones. So here after leaving those bad stones, we need to see that how many good stones are there in the river, from where we can safely land to the shore, that means out of the river. So first we will go through this example. So here it is saying the input is 2 3 minus 1 2 minus 2 4 1. Here the output is 3. How the output is 3, we will go through the explanation. Here it is saying that index 3 5 6 are safe only, as index 1 4 2 forms a cycle, and from index 0 you can go to index 2, which is a part of cycle. Okay, so here if a geek is starting with first index, see here the option is that here it is clearly said the initially geek can step on any stone. So if geek is starting from the first stone, that is index 0 1, then from here it is said 2, the value of this stone is 2, so and it is positive, so he can move 2 step forward. He will reach to minus 1. Since he will reach to this index which is 2, and here the value is minus 1, so once this negative value is encountered, so it will move the particular value number in the left direction. Here it is minus 1, so one step in the left direction. From here it is saying positive 3, then 1 2 3, positive movement towards the right direction in the positive direction up to 3 steps. But here again we can see here the value is 2, so here again it will go to minus 1, from here it will minus 1 again 3, then from 3 to again minus 2. So this will become a never ending loop if a geek is starting with index position 0, with case of this example. So here we need to avoid these stones, and we can see that if we can directly start with this stone where it is grayed out, here it is saying stone number 3, or index stone at index number 3, and from there these two also. So we need to find how many number of good stones are there. So here whatever we have discussed, the approach, same thing we will try here. What we will do, we will start coding for this one. First we will create an array. First we will create an array here, which we can give name as int, just give it some name dp, something like that, and we can give it as new int array of n. So this is to hold the number of steps that have been visited. Okay, so I'll just explain that as well. So initially, first we are initializing this one, we are creating this array, and what we will do, we will fill this complete array with -1, initializing this with -1. That means arrays dot fill dp with -1. We are doing this to say that none of the nodes are visited initially. Okay, so the next step would be, just a minute. So here we are initializing everything with -1, which will be used to store the number of ways each stone can be reached without getting stuck in a loop. So this dp, we will be using it to store the values. That means you to store the number of ways each stone can be reached without getting stuck in a loop. Okay, so initially we are initializing it with 0, with -1. Then what we can do now, here we can start our, once this is done, then we can start our iteration saying for loop. We'll start with int I, saying starting with the first point, that means stone number 0. Then I will go up to n, the number of stones we have, and we can increment at every step. So after that we have to find number of ways. So just create a method number of ways. Each stone can be reached without getting stuck in a loop. So we will check for each stone there. So we'll start with this I, and we'll pass that array. So once this is done, then what we can do, we can, here it is ending. So now let's go ahead and code this one. So it will be private int, with just a number of ways. I'm just coding this method here, and here I'll accept current, then int array of array. Here I'll explain that what all steps we are doing in sequence. So here, suppose if we are at any point, if our current becomes, if at any point the current value, that is indicating the stone index number, if that is less than 0, or current greater than array dot length. So if we are having either of these two conditions, then we can say that we are already out of that loop. That means from where we can be in trap, because we are already outside this one. That means this index, that means these stones, we are already outside these stones. So we can just return 1, indicating that we have found one ways. If we are avoiding these all stones and we are outside this, then we can clearly say that yes, we have found the one. So if either of these two conditions meet, then we can simply return 1. Suppose if we are at 4, so here it says that after 4, if at this index 4, it can move to 4 positive direction, then we are already out. And once we move these 4 step ahead in the right direction, then we are already out of this this entire stones, the stone sets. So from there we can say yes, this is one way, so we will return 1. Here in case of even here, if we are at 2, then from here we can reach 4, then from 4 to outside. If we are at 1, then only one step is needed. So in all these conditions, we'll be taking care of those things. Yeah, but at any moment, if we are outside, this current is less than 0, or current is greater than the complete array length, then we will return 1. Else If this is not the case, Control Z. Yeah, if this is not the case, then we need to check if that particular stone is visited or not. So if dp of current is greater than or equal to 0, you remember initially we have filled it with -1, saying that none of them are have been visited. So as and when it will be visited, we will be marking it with either 0, or if we found some ways, then we will store some positive number in that one. So if it is greater than 0, then this means we have already visited this, and we can return whatever the number is there, number assigned there. So return dp of current. Else, even if this is also not the case, then here we'll mark that particular stone as visited. dp of current is equal to 0. Then dp of, see, once we are at any position, we are marking so that we are at particular stone, we are marking it as visited, then we need to see the subsequent steps, subsequent stones. That means what all positive, what all options we have for other stones to be reached from that particular stone. We will explore that options. So for that, to this one we can add dp of current plus, we'll call this method again, saying called recursively. Just copy this variable name, method name, and here what I'll pass here current plus array of current and this array. So see here, I'll explain. If we are at this node, this stone, then for that next we have to check this one, current plus value in that particular stone. So initially it is at 0. So to this 0 we'll add the value whatever we are getting here, 2. So the index location was 0 plus 2 is equal to 2. So that step it will move further, and that will become our new index that will be coming to this method, and that will act as our current stone. So from this 2, 0 plus 2, after taking a leap of 2 in the right direction, since it is positive, so now we are at this one. Now we are at this position, saying that is our current value. Okay, so that's why and once this is done, then after that, from here what we will do to this index, we will add -1, and we'll see it will move to backward direction, and from there we will add +1. So whatever the steps we are doing, so that will be doing for all the stones. Okay, so once this is done, then at the end here return dp of current. So the same approach we will be doing it for all the stones. This example I have just gave for first one, but we need to do this for all the arrays. And once this is done, then okay, so here then we need to check. Once we have found the number of ways, that means we have populated our this dp array with the number of ways we have, so that we can skip those loop. Then what we will do here, we can just initialize a counter, int count is equal to 0. Then just copy this one. I need a for loop, Control Z, Control C. Oh, This time I could have typed it. Control C, Control V. So once we have found the number of ways for all the stones, then what we can do here, we can check that how many cell of this DP node has the value greater than 0. So greater than 0, it is saying that it has found some positive way. That means some ways from where we can skip those loops. So dp of 0, here we have a variable there, dp of I, here also I is needed, dp of I greater than 0. Greater than 0, if this is there, then we say count is equal to, count plus is equal to dp of I. So we will add all the nodes where we got some positive value. That value we will add and we will say yes, that this is our output. So from here we need to return the count. So here we will return the count. Okay. So here I'll just try to explain it again, the entire thing. So here if you can see that this good stone method, this takes two argument in, and that is n and array. N is the number of stones in the river, and array is the array of integer representing the values of each stone. The purpose of this method to calculate the number of good stones in the river. Okay, so first we initialize the dp array to an array of -1. Okay, which will be used to store the number of ways each stone can be reached without getting stuck in a loop. It then iterates through the stones in the river, and from there we are calling number of ways method for each stone. After each stone has been visited and their number of ways have been calculated, that means that we are doing here in this one, then this method iterates over the dp array, and it will count the number of stones with the positive values. So number of positive values, so that will return the number of good stones, and finally we are returning the count from this method. And if we talk about this number of ways method, then what we are doing here, so this is a private this is a method which takes two argument, that is current and in that integer array. Current represents the current stone on which the geek is on at the current moment, and array is the array of the values on the stones. The purpose of this method is to calculate the number of ways geek can travel from the current stone to the end of the river without getting stuck in the loop. The first condition here, it checks if the current stone is out of bound. That means either it is before the first stone or after the last stone. If this is the case, we simply return 1. The second condition checks if the current stone has already been visited and its number of ways has already been calculated. That is the value is already stored in the dp array. In that case, we simply return whatever the value stored in the dp array. If both these things are not there, then what we can do, we can set the value of dp array at the correct index to 0, which will indicate that this has been visited, and then recursively call number of ways array with the argument current plus array of current. That is, next stone the geek will step on. So if you add the value of array plus array of current to the current one, so that will be the particular stone the geek will step on. The value returned from the recursive call is added to the dp array at the correct index, and the method returns the value stored in the dp array at the current index. Okay, so I hope this is clear. So now let's try compiling this code. Oh, something. Line number 65. Oh, again, here also it's missed. I. Okay. Let's try compiling it again. Okay, here we are. Okay, see, this is a static one. Okay, so private static. Okay, here the variable name is current, not current with proper spelling. It's the variable name is just CUR. Oh, DP is not available where I have initialized the DP. Okay, okay. So here, one mistake. Since this has been used in the second method as well, so I need to define it globally. So what I can do here in the class level, I can just define private int array dp, so that it can be accessible, it can be visible to all the methods. So now just call it dp here. So okay, now let's try compiling again. Okay, so static. Now it is saying the index 7 out of bound for 7, line number 84. 84. If good stones 68, it is in 84. If dp of current is greater than equal to 0, okay, so here if current is equal to the array length, so okay, so even that is fine. Okay, because we have, at least we will have some positive number after that, so we can directly skip that infinite loop. Okay, so here you can see uh, that we have got our output here. So now let's try submitting the solution. Okay, so here we can see we have got all the test cases passed. So we have solved this problem successfully. Yeah, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. If you have any doubt related to this video or this solution, you can comment on this video. Yeah, that's all. Thanks for watching.